I had this as an assignment at some point for this course, maybe a decade ago. So what is this? This here is a calculator. They invented them just as I was going into high school. In fact, what was funny is I got one just as I went into high school, and it came with a manual that was this thick. It was the biggest manual ever, and all it did was your basic math, right? But I read the manual, in which case I then knew all the math I was going to learn at high school for the next 3 years, and the teacher told me not to come anymore. So anyway, what do you do with this calculator? It's a finite state, right? It has, what is it doing? It's remembering something in its accumulator, right? So here's a value in the accumulator, and it has some range up to 10 to the 8, right? And it has some other value which is on the screen, right? And then, so that's, and it has something to say whether, am I showing this value on the screen or am I showing this value on the screen? It has some other simple states, right? But that's the state of the machine, right? And maybe we have 38 here, right? And then the input comes, and the input hits a 9. And so then it says change state to this state, right? And then the input hits a 2, and so we change this state. And this one has another number in it, and then you push the plus, right? And what happens when it hits the plus? It takes this number and then adds it to this number and replace it with the sum. That's what happens when you're in hit a plus. And you can see it's just a state change. I'm in the state where I know this number and this number. I know them. So I'm in this state that knows all of this stuff. Somebody hits the plus. I just do table lookup to decide what state I should be in next, right? And what state I'm in next is the state that has this number here, right? And remember what we said is Pooh Bear can do anything based on what it knows. What it knows is what state it's in, right? So in one time step, it can do addition. Can it do addition of any integers? Only ones that it can remember. It only can remember numbers up to 10 to the 8, right? So if in your computer it stored a number 10 to the 8 and another number in 10 to the 8, in one clock cycle, is it really percolating through AND or NOT gates? Yeah, it is. But those are hardware built in, telling you what the next delta is, what the next state is. And then in one time step, we get the next state, right? So when you're buying a computer, then you can ask, well, how fast is the clock cycle? But you can also ask, what operations are built into your computer that it can do in one time step, right? I'm a couple decades behind this, so don't quote me on anything. But my sense was computers started having very simple instruction sets. You know, maybe they didn't even know how to add. So if you wanted to add, you had to write an algorithm to add in many time steps, right? But then they got more and more complex CPUs so that you could add and multiply 8-digit numbers in one time step, right? And maybe you could do Fourier transforms in one time step, right? And then my understanding is that they went back to really simple machines, that really all you could do is one little thing at a time, and they built into software to be able to do the other things, right? So you might know more about what they do now. Everybody get this? It's just a finite automata. Here it is, I'm in the state. What do I know? Right, I'm a state. I know the value in the accumulator, my current value on the screen, right? I get a character. What do? The current value on the screen increases it's multiplied by 10 and you add the character. What is that doing? That's putting in, I multiply this by 10 and I add a character. Right? Everybody buy that? And then, and I keep showing, and I'm in the state that keeps showing something. And you know, there's no output here. Right? Like in the other example where we said hi, that's not happening. It's just, I'm in this state, and if I'm in the state where I show values, this value that's on the screen, the current value, then the current value is on the screen. Right? And now I'm in the, I have accumulator value, I have a current value, I'm looking at the value that's, you know, what something's on the screen. I hit the plus, and what happens? My accumulator gets, the value on the screen gets added to the accumulator. Right? People see that? You clear everybody. Right? We just made a simple adder. All right? Does that make sense? So these things are useful as a concept. Yeah.
For the last one, when we clear it, why don't we show 0, or it shows 0 apart?
Well, we're showing what's in the what's in the current value, and the current value is 0, so 0 will definitely go on the screen because it's showing this value. Yeah? Everybody get these machines? Yeah?
Show C and show A are just displaying.
It just tells you, it's a bit that tells me of the state, which tells me, do I display this number, Right? I wanted to be able to, somehow at some point, right, I'm accumulating things. At some point I need to be able to look at what I've accumulated. Right? So somehow that needs to be built in. And you know, this is way simple, and I made it up. So I've never taken a course on calculators. Right? So don't quote me on the nuances of state diagram of this thing, right? But you can imagine that DFAs help us here.